All right, let's get straight to it. The software-defined vehicle is no longer just some far-off concept. It's the new reality we're all engineering for. But the real challenge has completely shifted. It's not about if you can build an SDV anymore. It's about how you manage its absolutely mind-boggling complexity. So in this explainer, we're going to cut through all that noise and give you the technical playbook you need to really dominate this new era.
Look, the days of just experimenting with software in cars, those are long gone. We are now deep in the era of industrialization. And what that means is a massive, and I mean massive, leap in complexity. We're talking a 100-fold increase. This isn't just a small step forward, it's a complete revolution in how we engineer vehicles.
So what does this actually mean for you, on your team, on your project? Well, it means the entire focus has changed. This is no longer a race to add the flashiest features. The real battle, the one that will define the winners and losers, is in mastering the underlying complexity of the system. If you get this right, you build a platform that can grow, adapt, and win for years. But if you get it wrong, you risk building a product that's already a museum piece before it even hits the showroom.
So the big question is, how do we get our arms around this beast of complexity? It really starts with a fundamental rethink of the vehicle's core architecture. Our analysis shows it all boils down to 3 absolutely non-negotiable paradigm shifts. You can think of these as the new rules of the game.
So let's break these down, one by one, and we're going to start at the very foundation of any modern vehicle, how all of its different systems actually talk to each other.
Okay, the first huge shift is moving away from that old model, where one component is constantly having to ask another, hey, what's the current speed? Hey, what's the current speed? We are moving to a data-centric model. The best way to think about it is like a newspaper subscription. Your app, it just subscribes to the speed topic, and that data is automatically delivered anytime it's updated. This decouples everything, and that makes the whole system way more flexible. And this is where it gets really powerful. We're leaving behind these closed-off, auto-specific systems like SUM/IP, and we're adopting open standards like DDS and Zeno. Now, these have been battle-tested for years in industries like aerospace and robotics. So why does this matter so much? Well, because it means faster innovation, it breaks that dreaded vendor lock-in, and it lets us build a much more flexible, future-proof architecture.
And here's the kicker. This new approach is unbelievably efficient. A protocol like Zeno has a minimum wire overhead of just 5 bytes. Now, 5 bytes might not sound like a lot, but trust me, when you have hundreds of sensors all chattering away at the same time, it is a massive advantage. It means we can use smaller, cheaper, and more readily available microcontrollers and still get the incredible performance we need across the entire vehicle.
All right, on to our second big shift, the vehicle's operating system. Forget about a single, monolithic OS trying to do everything. That is old news. The modern SDV uses a layered approach, kind of like a 3-layer cake, where each layer of the software stack is perfectly optimized for one specific job.
So, at the very top, for everything the user sees and touches, the winning strategy is to leverage the power of Android. And why is that? It's simple. It gives us instant access to a global ecosystem of millions of app developers. And that is how we're going to transform the car into a true platform for innovation, where you can deploy new features and services as easily as updating an app on your phone.
Now, in the middle, we have the safety and compute layer. And this solves a huge headache for all of us. How do you use the power and flexibility of open source software like Linux, but still meet the absolute non-negotiable safety requirements of our industry? The solution is a hardened, certified version of Linux that gives us a proper ASIL-rated environment. It really is the best of both worlds, open innovation and certifiable safety. And then, down at the foundation, we have the real-time control layer. This is where we get really smart and lean. For simple, predictable tasks like, controlling a window motor, we don't need a super powerful, expensive computer. We use highly optimized software on a tiny, efficient microcontroller. It's all about aggressively applying the right tool for the right job to keep costs and complexity under control.
Okay, our third and final paradigm shift, and this one's a big one. It's all about how we develop and test our software. The core idea here is something called bit parity. And what this means is that the code you're testing in your virtual, cloud-based environment is identical bit for bit to the binary that will eventually run on the physical chip in the car. Why is this so critical? Because it completely eliminates the risk of those awful, last-minute integration surprises. It lets us validate our software much earlier in the process.
Honestly, this is a total game changer. We're moving away from that old, slow, painful process of waiting for physical hardware to show up before we can even start testing.
With a cloud-based digital twin, we can start development and run massive-scale validation from day one. This doesn't just make things faster. It fundamentally changes the economics and the entire timeline of vehicle development.
And let me be clear, this is not just some theory. By using AI to create and run millions of virtual test scenarios in the cloud, we can slash the need for expensive, time-consuming physical fleet testing by as much as 70%. That is a massive gain in efficiency that translates directly into a serious competitive advantage.
So, we have these three huge shifts happening all across the globe. But here's the thing, not everyone is playing the game the same way. The global race is definitely on, so let's take a quick look at how the different key regions are tackling this whole SDV challenge.
Okay, over in North America, the main focus is on perfecting that core vehicle architecture. You've got companies like Tesla that have a pretty significant head start here. The strategy is really a walled garden approach. Control and perfect the platform first, and then maybe think about opening it up later. The upside is a tightly integrated, really high-quality user experience. The potential downside, well, it can slow down innovation from the wider ecosystem.
China, on the other hand, is all about speed to market. They are embracing new technologies and opening up their platforms to developers at just an incredible pace. The goal is simple: capture the market for in-car digital services as fast as humanly possible. The risk there, of course, is that when you're racing for speed, you might end up compromising on long-term quality or security.
And then you have Europe, which is taking a more deliberate, more methodical, long-term approach. The focus there is squarely on safety, security, and industry-wide collaboration. By working together on standards, European automakers are essentially building a strategic defense, hoping to create a level playing field and prevent just a few outside tech giants from controlling the entire automotive world.
Okay, so we've talked about the architectural shifts, we've looked at the global landscape. What does this all mean for you, for the engineers actually doing the work? Let's boil it down to 4 concrete strategic actions you can take right now to put your team on the path to success. First and foremost, we have to stop wasting our most valuable engineering resources on what I call the plumbing. Right now, teams are spending up to half of their entire R&D budget on just basic integration work. That is time and money and talent that could be spent building the features that customers actually see, use, and are willing to pay for.
So here it is, your 4-part playbook. Number 1, stop buying parts, start buying platforms. Procure hardware and software that are pre-integrated and designed to work together right out of the box. Number 2, rethink your entire communication backbone. It's time to adopt modern data-centric protocols like Xeno and DDS. 3, build your software factory in the cloud. You have to embrace bit parity to accelerate development. And finally, number 4, get lean on the edge. Use the right-sized, most cost-optimized solution for every single job.
So, I'll just leave you with this one final question to think about. In the race to build the car of the future, who wins? Is it the team that's stuck down in the weeds, fighting brutal integration battles day after day? Or is it the team that has industrialized its platform so they can focus all their energy on delivering the features and experiences that are actually going to delight customers? The choice is yours.